Okay, so in this video, I'm going to solve a question on quadratic splines. Okay, so I have a couple of questions from interpolation, but I've just picked question number 6. This is a question that I'll focus on this video. Okay, so the question reads, given the data 0, 0, 1, 1, and 2, 4, okay, fit a quadratic spline into the function defined by the this set of points. Okay, use it to approximate f of 1.5. So we want to fit a quadratic spline to the function defined by this set of points, and also we have to use it to approximate f of 1.5. Okay, so I'll write the points 0, 0, 1, 1, 2, 4. So given the points here, so these are points given. So the points given of 0, 0, 1, 1, and 2, 4. So we want to find a quadratic spline that will interpolate these points here. Okay, so quadratic spline is given by s of x, the set of piecewise functions. Okay, the quadratic functions, of course. So we're going to have the first piecewise function as s1 of x equal to a naught plus b naught x plus c naught x squared. Okay, and this spline will be in the range of x. So the x naught is this one here to 1. Okay, so this is x naught, this is x1, or this is x2. Okay, so this will be in the range from 0 to 1. So we could say the values of x will belong to the set 0 to 1. The next one we're going to have is s2 of x. S2 of x will be equal to a1 plus b1 of x plus c1 of x squared, and this will belong to the x values from 1 to 2. Okay, so from 1 to 2. All right, so now the first thing is for us to, okay, let me just sketch a bit of this. For instance, we have those data points given. Okay, so we point here at the origin 0, 0. Okay, our point at the origin is 0, 0. You also have another point at 1, 1. Okay, so 1, 1 somewhere here. And you also have another point at 2, 4. Let's say 2, 4 somewhere here. Okay, so now we have to find these equations that we want to approximate the equation that will approximate this curve here. Okay, that will approximate this curve. So we're going to have the first piecewise equation from here to here. Okay, the second one will be from the second point here to the third point there. So I'll find these two functions are the one we're actually trying to find here. Okay, so now the first condition, there are a couple of conditions actually. Okay, so the first one, we're going to evaluate this s1 of x at this endpoint here. Okay, we have to evaluate this s1 of x at that endpoint here, and this happens at the value of x equal to 0. So just get the value of x and replace it in the equation there. Okay, so let's go ahead and do that. So we're going to say s1 at x naught, okay, should be equal to the function itself at that point. Okay, so what is f of x naught? F of x naught is the y value corresponding to the x value given. So this is the f of x naught, okay, corresponding to that x naught. Okay, so we substitute values, substitute 0 in the equation. Of course, the first equation, so we're going to have a0 plus b0 times 1, so times 0, plus c of 0, then 0 squared, equal to f of 0 at that point f of 0 is equal to 0. So if we simplify here, you notice that our a0 just be equal to 0. Okay, that's our a0. Next, we also have to evaluate the same function. Okay, remember this equation is connected to 2 points, right? This point and this point. So I have to evaluate this function on the next point as well. So we're going to say S1 at next point, which is x1, should be equal to f of x1. Okay, so we substitute the value of x1 in the first equation given. So our x1 in this case is 1. So a0 plus b0 times 1 plus c0 times 1 squared. Okay, so squared equal to f of x1. What's the value of the function at that point? It's equal to 1. Okay, so we end up having our first equation, a naught plus b naught plus c naught equal to 1. So I'll call this equation number 1. Okay, all right, and then we are done with that, of course. The next one is this equation now. Okay, so this equation also we're going to evaluate at this point here, which is x1. So equation number 2 as our s2. So s2 evaluate that x of 1 equal to f of x at that point. Okay, so we substitute 1 in that function. So we're going to have a1 plus b1 times 1 plus c1 times 1 squared equal to f of x1 at that point simply equal to 1. So we have a1 plus b1 plus c1 equal to 1. So this will equate to my equation number 2. Okay, again, I have to evaluate this guy, this function at its endpoint, which is what? 2. Again, so I'll say S2 evaluating at x2 is equal to f of x2. Okay, so we substitute the value of x2. Our x2 is equal to, so we have a1 plus b1 of 2 plus c1 of 2 squared equal to f of x2. F of x2 at that point is simply equal to 4 here, right? That's the value of the function at that point. Equal to 4. So a1 plus 2b1 plus 4c1 equal to 4. So this will be our equation number 3. Okay, so we're done with the first conditions. The next condition, we have to make sure that our function, okay, our piecewise function are continuous, okay, at that common point. What is our common point? Our common point is 1, right? When x is equal to 1, that's a common point. So these piecewise functions must be continuous at that point. Remember that we're trying to join 2 functions to approximate a particular function, right? So they must be continuous on that particular that common point. So their derivatives must be the same. So what I'm trying to say here is that the derivative of s1 at that point, and that point is simply x1, right? x1 is common. Sorry. Should be equal to the derivative of x2 at that point. Okay, so let's get the derivative of those 2 functions here. So the derivative of x1, so differentiating x1, of course. Okay, so differentiating x1, I was doing here. So the derivative of x1 will just be what? A naught to go, just going to have b naught plus 2 c naught x, right? Should be equal to the derivative of x s2, and then a1 also will go here, just going to have b1 plus 2 c1 of x. And then evaluating at what point? The point is x2, so this must be x1, right? The point is x1, not x2. So b naught plus 2 c naught. The point is x1, our x1 simply equal to 1 equal to b1 plus 2c1 1, right? So from this, you just have b0 plus 2c0 equal to b1 plus 2c1. So I'll call this equation number 4. Okay, now one more condition, and another condition you need to consider always when you're doing with cubic spline. The last one is actually the second derivative of S1 evaluated at the x0 must be equal to 0. Okay, so that's another, we call it a complementary solution, right? Equation. So we need to find the derivative of S0, which is the second derivative, so S1. So we just have to take the derivative of this guy here. Okay, so B0 to disappear, just going to remain with what? 2C0, and this must be equal to 0. So this clearly states that our C0 is equal to 0. Okay, so found the 2 unknowns. We're remaining with how many? 4 more, isn't it? So in fact, from equation number 1, okay, from equation number 1 we formed, remember that A0 is already known, right? So A0 is already equal to what? Equal to 0. So let's get equation number 1. Equation number 1 of A0 plus B0 plus C0 equal to 1. Okay, yeah, of course, equal to 1, I think. Yeah, so we already know for A0, A0 is equal to 0. B0, you know, we already just found C0 is equal to 0. So we can find it B0 here. So our B0 is simply equal to 1. Okay, so found B0. So from the first equation, we found all the unknowns. Now we go to the second, to the other equations. So allow me to pick these equations here. So we have equation number 2, A1 plus B1 plus C1 equal to 1. Okay, so A1 plus B1 plus C1 equal to 1. The other equation we have is A1 plus 2B1 plus 4C1 equal to 4. So A1 plus 2B1 plus 4C1 equal to 4. And also we have this equation here, B0 plus 2C0 equal to B1 plus 2C1. Okay, so I'll write it as B1 plus 2C1. So B1 plus 2C1 equal to B0 plus 2C0. But we already found C0, right? C0 is equal to 0 from here. And also we found B0 equal to 1. So this equation just be equal to 1. Okay, so now we have 3 equations, 3 unknowns. So we can solve these equations using the systems of equation. Okay, we know how to solve. We can use the elimination, substitution, whichever, Gauss elimination method, and so many other methods you can apply here. So I'll just go for elimination. So from the equation number 2 and equation number 1, I'll combine those by eliminating A1. So I'll subtract equation 1. Okay, I'll subtract equation 2 from equation 1. Okay, or it's other way around. So I'll do this equation minus the second equation. So notice that A1 and A1 will subtract, B1 minus 2B1 just be negative B1. C1 minus 4C1 just be negative 3C1. And then 1 minus 4 just be negative 3. Okay, so you can divide throughout by negative 1. So we have B1 plus 3C1 is equal to 3. And then I'll solve this with the third equation. The third equation is B1 plus 2C1 equal to 1. So I can actually apply elimination here, just subtracting again these two equations. B1 minus B1 just equal to 0. 3C1 minus 2C1 just be C1. 3 minus 1, we have 2, right? So our C1 is equal to 2. Okay, so that is our C1. And then you can get our P1 from this using either of those equations. So in this equation here, so our B1 plus 2, our C1 is 2 equal to 1. So this tells us that our B1 is simply equal to -3. Okay, so we get our B1, which is equal to -3. Okay, so we found our B1. Lastly, let's go ahead and find our A1. Okay, so our A1 can be found from any of those equations, equation 1 or equation 2. So from equation 1, we have A1 plus B1 plus C1 equal to 1. So our A1 is unknown, B1 is -3, C1 is +2, and this is equal to 1. So this is the A1 just equal to 2. Okay. So of all the unknowns we wanted, then we can write our quadratic spline. Okay, so we can say S of x is equal to, okay, so S1 of x, what is S1 of x? A0 found to be 0, B0 was what? Or B0 was simply equal to 1. So B0 is actually the coefficient of x, so we're going to have just x here. C0 again was equal to 0. So our C1 just be equal to x, and this for the values of x from one interval from 0 to 1, right? Okay. And then our C2 of x equal to our A1. What was the value of A1? Okay, we're just trying to substitute in these equations we formed here. Okay, so our A1 is equal to, okay, where did I write A1 here? Okay, so did I even, but I'm just from solving A1, which is 2. Okay, our A1 is 2. Our B1 is -3. So this B1 is simply coefficient of x. And then our C1 is equal to 2. So 2 x squared. And this happens for the values of x from 1 to 2. Okay. So now the second part of the question says we also have to evaluate this at what? F of 1.5 here, right? We have to evaluate at F of 1.5. Okay, so how do you evaluate at F of 1.5? So just substituting the value of x in our splines. Now let's take note here. Let's be careful. 1.5 is in which interval? 1.5 is actually in this interval, right? So I have to substitute in this function here. Can't substitute 1.5 in this because you don't have 1.5 in that interval there. Okay, so it means that our s of 1.5, we're going to substitute for this equation, right? So this will be equal to 2 minus 3, 1.5 plus 2, 1.5 squared. Okay, so how much is that? So 2 minus 3 times 1.5 plus 2 times 1.5 squared. So I'm getting the answer equal to 2. Okay, so and this okay, because you notice that at 2 we have 4, right? So you can't have 1.5 to have a value of more than 4. That's not possible. Okay, yeah, unless maybe the function has some twist somewhere and all that. So this is equal to 2, so that's the final answer. So thank you so much for your attention. Be on the lookout. I'll post all the videos. Okay, all these questions you are seeing here. I'll post the videos. Actually, I already posted for question number 1. You can go and watch my playlist on numerical analysis. Question number 2 is solved already. Okay, and as well as okay, I need to make a video on question number 3. So just be on the lookout. Keep checking my YouTube channel. You're going to find all these videos. Okay, and also I'm going to make videos on the cubic spline and all that. Okay, so thank you so much for your attention. May God bless you all. Okay.